Hello everyone, I'm Vivekanand Talgade, your chemistry instructor. So as we are dealing with the polymers, we shall now speak about the biodegradable polymers. Basically, when we look at the polymers, what we observe is these particular polymers, right? These particular polymers are actually resistant to the environmental degradation. Okay, because of their resistivity to environmental degradation, these have been causing a problem. Okay, these have been causing a lot of problem in the form of these solid wastes, which is causing acute environmental pollution. All right. So because of this, what happens is we need to synthesize, we actually are synthesizing the polymers. These polymers, these specific polymers, okay, these specific polymers which have the functional groups. Okay, the important thing is here, the functional groups which are similar to those functional groups which are found, okay, which we see, which are found in the biopolymers. Okay, so whatever the biopolymers are there, like the cellulose, starch, and all, correct. So in those particular things, what are the functional groups? So incorporating these functional groups into the polymers that we synthesize, okay, whatever the polymers that we synthesize, these polymers then they will have the properties such as the biodegradability. So these are biodegradable. Okay. Now, how is this particular thing biodegradable? It is biodegradable by the enzyme activities. Okay, or by the enzyme catalysis of bacteria or the bacterial activities. So, due to the bacterial activities, what is going to happen now is that these bacterial activities, such as the enzyme catalysis, will break down these polymers into smaller fragments. Okay, now when they break down these particular polymers into smaller fragments, these are actually degrading it. Okay, so as they are degrading it, it won't cause any problem to the environment. So this is all about the biodegradable polymers. We will see about the examples. So a large number of polymers are quite resistant to the environmental degradation process, and those are the responsible for the accumulation of polymer solid wastes. These solid wastes are causing the acute environmental problems, and they remain undegraded for a very great long time. In the view of general awareness, certain new biodegradable polymers have been synthesized. Correct. Now, these particular polymers, what they are going to have? They are going to have certain functional groups which are similar to the functional groups which are present in our biopolymers. Okay, so that is the important point that you have to remember. Okay, so therefore, these polymers can be broken down into the small segment by the enzyme catalyzed reactions. Okay, so they require the enzymes which are required, these are produced by the microorganisms. Now, let us observe one example. The example which we have to learn here is called as PHBV. Okay, remember this? It is called as PHBV. Now, what exactly is this particular PHBV? It is poly beta hydroxy butyrate co beta hydroxy valerate. Okay, so this is the biodegradable polymer that we need to study. So when we observe this, this is a combination of the two monomeric units, and hence two different monomeric units, and hence this particular polymer is actually a copolymer, right? So it is actually made up of the monomer, which is 3-hydroxy butanoic, butanoic acid. Okay, this particular butanoic acid is going to combine with the 3-hydroxy pentanoic acid. Okay, now when these particular things are going to get combined, it is going to give rise to the main polymer. And the particular main polymer, okay, in order to go for this, let's first take down the structures. So the structures that we have, n number of CH3COH, right? So here HCH2 COOH. So total number of carbons 1, 2, 3, and 4. So therefore it's a 3-hydroxy 1, 2, 3, 3-hydroxy butanoic acid. Right? So here the same way that we have is n number of, let's take over here OH connected to C, CH2, CH3, 1, 2, 3, 4, and COOH. Right? So now when we observe the polymerization, we will see that it gets polymerized at this particular position. Okay, so O, correct? CH, this is CH3, CH2, C. Okay, double bond O. Now this H and this particular thing gets eliminated as water. So therefore, what we are going to have O, CH, CH2, CH3, CH2, COOH. So 1, 2, 3, 4, 5. Correct. So one second. So as this is a polymer, what we are going to have here is C double bond O, and this particular thing continues as N times. Right? So when we have this particular polymer, right? This polymer is a PHBV, and that is nothing more than polybeta hydroxy butyrate co-beta hydroxy valerate, right? So let's observe it in a proper way. So polybeta hydroxy butyrate co-beta hydroxy valerate. So it's actually a thermoplastic copolymer of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid, in which the two monomeric units are connected by the ester linkages. Correct. So now here both of them are going to have certain properties. Okay, depending upon how much ratio of 3-hydroxybutanoic acid is there and how much ratio of 3-hydroxypentanoic acid is there. Okay, now 3-hydroxybutanoic acid is going to give stiffness to this particular polymer, copolymer, of course. Okay, while 3-hydroxypentanoic acid is going to yield flexibility to the copolymer. Okay, now this particular polymer is very useful in the orthopedic devices. Okay, it is also useful in the drug delivery controlled tablets or the what we can call it as capsules. So when we observe its importance, we find its importance in the orthopedic devices in controlled drug release capsules. Correct. So this was about PHBV. The important fact about this is that this particular polymer gets degraded in the body. That is, PHBV also undergoes bacterial degradation when we leave it out into the environment. And hence, it does not cause any harm to the environment. Right? So, let's observe the next point. The next important point of the discussion is about the nylon to nylon 6. Okay, now this nylon to nylon 6 is an alternative polyamide of glycine and aminocaproic acid. Okay, as a result of which, let's observe here. So, glycine, n amount of glycine, that is NH2, connected to CH2 COOH, correct? So now these particular polymers are going to be formed by glycine, right? Along with it, it is going to react with the N-aminocaproic acid. So N amount of aminocaproic acid, NH2. Okay, let me represent it as NH2, CH2 5 times here, COOH, correct. Now when we are going to have this, that is the aminocaproic acid. These are going to get polymerized, and again, we know how the polymerization action works. That is between these, correct, a particular bond is formed. So same thing happens at NH, CH2, C double bond O. This particular thing goes over here, NH, CH2, 5 times COO, right? C double bond O, and this thing continues. So here, right, N times. So this is our nylon to nylon 6. Okay, now let's observe. It is an alternating polyamide of the glycine and the aminocaproic acid, or 6-aminohexanoic acid. So when we take the glycine and react it with the aminocaproic acid, we end up getting the nylon 2, nylon 6 along with the elimination of certain amount of water, right? Now, it is actually a biodegradable polymer, which is a step growth polymer, right? So thank you. This ends the session for today. Do take care. Thank you for watching.